So let's describe what ECBIP means. It's encrypted compressed breakout internet protocol. It's a way to work around the ISP, is what I was just talking about in my apartment before I decided to do this recording. So whoever's there, that's along for the ride. There you go. But it was like, all right, so here's the thing. I have like no computers, right? Like, well, I have computers, but like they're not very strong or very powerful computers. So the reason why I came up with a God operating like system was I needed a dynamic a parallelizer program, but then also I needed to not be a parallelizer. I needed to be, able to ascertain the fastest methodology to using the least amount of, singular bit information to process things, alongside of doing it with the fewest amount of transistors possible to allow for it to have done whatever calculations necessary and to perform the necessary actions to have the information. So I was talking about it. It's like, well, here's the thing with my information stuff. So it's like, well, I don't have a lot of memory either. You know what I mean? So it's like, how the hell do I compress memory, but like not make it insane? So it's like, I have a data set table. Well, not a data set table. They're binary tables. All right. So like binary tables alongside of like this given sequence that it stores. So it's like all it needs is like this means do these things. So like plus minus blah 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 for transistor and processing core or whatever stuff. Right. Okay. That's all a compression really means, because it's like, okay, and then that's that many binaries, whatever bits and then ultimately bytes at the end of it all that you get. That's the breakout. But it's like, I don't need to do anything except store the necessary proper breakouts to have all the information in real time for you to have at any given point. And so because it can do it dynamically, such that like it's as small of a amount of calculation as possible, which, that one's a pretty simple one. For what it's worth, I've gone over it a few times, but it's like the cache is what it is that I tend to manipulate alongside of the CPU's, actual binary. Because like I learned later that like CPUs are effectively just an analog computer kind of style of something that's really small, but like it has like stored on programming, which is like this capacitor versus this battery versus this modulation of like these transistor areas that do and have these given effects basically for their processing cores. And I'm like, yeah, so I'm just going to dynamically change that as necessary. Like I'm just not even going to fucking bother. And like that's my operating system, so it'll take like a little algorithm and a couple of binaries, and it'll just go and run through everything. So it knows the architecture, it knows everything on the motherboard, the RAM, all of the binary of every single processor, all of it. And it'll change it so that way it is as fast, connected, and as set up to have all that knowledge at once. All the timing, all of it. To be as fast and efficient at dynamically loading and parallelizing and then having all information arrive at the right times to have it have calculated anything at all, which is kind of what standard processors do anyways. But it's an operating system, and so it's like, let me just plug in this USB-C, and it's like, no, fuck you, that's not that. This is what it's doing. And it's like, that's all I needed to do. It's like, this is my mouse. It's like, you mean processor? You mean sensor data bullshit? Like, that's my calculator that's over there, and I have to wait this amount of time for it. That's what that really means. You mean this monitor? Oh yeah, no, you mean processor? So it's like a supercomputer stuff, where it's like, oh, it's over there, and I have to fetch information here, and it's like, well, no, I'll do a little calculating along the way until it gets to that, and I'll be doing all these other things over here, and then I'll arrive over here, and we'll do the calculate, and it's like, well, I'm only needing really for it to be a singular byte, and no way anymore, it's a bit, because like it'll break out that given bit as if it was the full byte of information, and it can have up to 4 different instances as to what that information really meant because of the cache and the sequencing of spitting out of the binary that's necessary for it to ultimately do whatever it was that it needed to do. Because that's all it is. It's like, so, the monitor needs this, sequence of ups and downs. Think switch turning, effectively. That then goes to over here in these pixel areas, this happened. You know what I mean? But it's like, no, fuck that. It's all analog now. I mean it. I'm like, literally, screw this crap. I'm not going to calculate like that. This has this given switch information for why it is that pixel does these things in these areas. And it has, all that shit. So it's like, it just makes it as efficient as possible. So it's like, these given all the way down to like sub-pixel areas, that's all you need to send for that information. And so like, it dynamically sends all of that at all times. Same thing with keystrokes, same thing with all of it, even internet coming in, internet going out. And this is why I'm going to talk about the internet protocol that I have. So it's like, look, I only have, literally, this is my real internet speeds. 10 megabit down, 1 megabit up. That is what I have. So I'm like, I need to work around this. So it's like this ISP and all the routers and everything have these given, values, effectively, of whatever their, programs are going to do and so on. So a way to work that out is like, I'm going to send an informational packet, the right amount, right? That goes, hey, this effectively breaks out like this. So it's like the CPU that's on the other side that I'm sending this information to will then break this out like that. Like it's compressed and like it's encrypted. Except it's not encrypted. There's no encryption. It's just setting up for it to go through and then have that information come out as if it's a much larger file, because it'll use all of its given clock cycles until it's done. And since they have a huge amount of that, it's like, well, along the way, I can have it break out, several times, until, like, it's effectively, oh, sure, I sent 1 megabit, right? Let's say it was 1 megabit, over that second. But it's not. It's 1 terabyte, that I'm like, let's just imagine. It's not, by the way, it's actually 8 gigabytes. That's what I'm sending out as a file. So say in 1 second, I'm going to send out 8 gigabytes. But for them, for a clock cycle, that'll be nothing. You see what I'm saying? The ISP, it all sent out as 1 megabit a second. Nothing changed. Meanwhile, their router, their information, how they process it as it comes in, is already starting the breakout process. Because it's already sending it to receive it like this and send it through and do that kind of a program move to their given processing and so on, binary, to do these things. So instead of it being malware or any of that, it just goes, here, you received a file like this. This is how actually many programmed packets of IP that you got. You know what I mean? Like this is like, oh, it's encrypted, quotation mark. It's compressed, quotation marks. But actually it's not. There's no encryption. There's no compression. It just and sent it through their CPU like it's an 8 gigabyte file because it has to go through like that. So instead of telling them all of this byte information, I'm just telling the processors to give them this information, to do this instruction, to give them and receive that as this file. And it's like the ISP's like, we're cool, everything's good, man. Literally, you sent 1 megabit. Meanwhile, let's say it was Google, YouTube here, that wants my video, right? I'm trying to upload to them. It's like, I now have an 8 gigabyte fucking file that I have to upload. Like, it happened to be there in a second. Who is on our network with fucking internet like that? I need to find this motherfucker. Who's got this terabyte a second bullshit? Or whatever it is, right? You know? Like, who's got this? And anyways, but their servers see it as if it uploaded as normal and as usual. Nothing in any way infected them. There's no, like, it'll continue. There's no any of that. It just gives them that information, and that's all it can do. It's literally all it can do. And so it's like, that's a way for me to get around this stupid fucking information problem. So all I need to do is have instruction sets and the correct bit information to allow for not just the instruction sets, but the amount of time for them to process it through, and also what it should be doing. You know, as in, like, these are the bytes for this to mean that this is that thing, right? Like, it's not just going to give you a whole bunch of instructions to then suddenly process, you got this big file, alright? It's like, no, this is a file, okay? Comes across as a file. It's just, no, you didn't understand. The file just needs to do these things, and then you can have it. And since it's so fast at doing it, which that one's really simple for me, it's like, look, I did a stupid algorithm for my operating system, which isn't really stupid, because all algorithms and equations are effectively the same thing to me. But I'm going to move off of that. Like, because it's like, oh, I'll send a 1 or 2 or whatever it is, right? For, you know, a number through given, like, numbers. And that's all an equation is. You know, it's a program. All algorithms, all equations are programs. That's all they are. It's like, on the whiteboard, there's stored in the cache here this information over here in parentheses and blah, 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 blah. And that's all it is. It's a program. And it's like, you can make them do anything if you know what you're doing. Like, saying, no. See, these are the instructions for this program. Actually, this does this. You think that does, but that's not what that is. I know you taught us all this stuff, and that's good, but that's not what that does. This is different instructions for these equations. And so, like, it'll send those instructions, and then it sends this information, and then it goes, stores this information that gets modulated by having the numbers run through the binary, and then it goes, this now came out like this, and then it stores that, of course, RAM or, you know, hard drive. But if you don't need it at all times, like, see, that's the thing, you know what I mean? Like, you don't need that to be stored like that. You don't ever need that to ever be stored that way. You don't need it all to be stored as, you know, the ones and zeros of the entire complete thing. Ever. But it's like, now it has all of it. Like, meaning, in this instance, enough for whenever you do anything to search through any of it, wherever it, let's say it was a book, okay, like you wanted to just go through all the pages of the book, all the words. It's really easy to calculate the fucking, you know, binary for any and all of the letters, real time. Like a freaking video game, effectively. Like any physics calculations, right? It's like, it's really super fast. Like, you never really need anything except for, like, this will just break out super fast from your cache and RAM, exchanging information between your like clicks and scrolls and everything. So it's like, I'm going to scroll this. It'll go like, oh, so it wants to go to this, and it's like that'll store that initial like, these given areas of pages, sections. So it's like 100, tens, whatever it is, and it's like this comes in as an instruction through all these areas on the motherboard until it gets to like, hey, so this is CPU. But it's like, no, no, no. So this now instructs it to RAM to send to CPU to send to your little, which isn't really going to do that. So it's like, this is actually stored in your GPU, which is going to go to your display, okay? And so like display is super simple, where it's like, just do these things and it showcases that. So it's like, this goes this amount of whatever it is, and so it's like, oh, it's going to this area to display that now. I don't need to calculate real time any of those things. It just needs to display ultimately what that will break out to for those instruction sets. I don't have to have all the knowledge on hand. It never will need that. You know what I mean? You'll never notice the difference. Literally ever. Meanwhile, it's like, that's just a background program. I can do multiple versions of that. You see what I'm saying? Like, I have freed up huge computational resources as a result. And because it stores given data sets, which are binary tables. Like, if you know anything about my operating system, it stores binary tables. So it's like, they're 4 by 4. So they're a table of 16 total bits. But those break out, given equations that you set up from the CPU and the program, okay, because they're going to talk. The architecture has a program, given, but it modulates itself so that way it's as efficient as possible. Not to mention, it's like it stores both on its base programming and its cache and everything, both the singular that it's doing that for, but then others that it's calculating for that given clock cycle. Kind of like hyperthreading, except instead of sending it in like a phase, like a DC phase, so it's like a sine wave, that's this one, but this one's really close by, and so then it comes by and it does something with the necessary time that it has to calculate. Well, fuck that. This sine wave is actually these given calculations through this area because cache and base level programming on CPU. And the program knows. Like, each program tells it that it's like, this is what it actually knows. That this is for that, that's for this. And it's like, you think, wait for this one, that it can't know that. Right? It's like, no. This binary, this one bit, right? This one bit can't possibly be used for these other pluses and minuses in these equations for this program over here. And I'm like, yes it can. Why? Why wouldn't it be able to be used that way? It's still the same plus and minus. I'm just going to have information stored for that. And then it'll break out over here in other areas of the CPU for its transistors and the processing cores to then brrr like that for its pin set to send off these binary bits or bytes of information. But it's like, if it has it over here and you're only going to display it like this, then I don't need it to go brrr with bunches and bunches of fucking bytes. Screw that. I only need the bits, the necessary amount of bits for it to know this is what this is this information it's calling to, like an IP protocol packet send. Just set it up ahead of time and then knock it down. And break it out to being, this is what this means, this is it, and then it sends out the next IP protocol to the monitor or the internet that we're talking about. So it's like, that's why my programming is usually considered insanely good. It's like, no. ISP, guess what? You didn't get worked around very much. In fact, I used the amounts you were allowing me to have. Okay? Like, that's all that was. I didn't do any malware infected anything to the Googies, the Google servers. None of that happened. I didn't do anything really untoward to your personal computers over there. And I didn't do anything bad on mine. I didn't malware infect. It stores your original binary and all of that as is, and it'll set it up as normal when you delete my operating system, if you should want to. But it's like the entirety of your every bit in bytes that can be calculated for all processors that you have is going to be used. Like, I don't need to calculate that amount. This will break it out over here on your displays processor. I just need to send this bit information that will display it like this in real time, calculating it like that. Because, like, that's an easy, simple thing to do. Like, it's already a known value, so it's like, it's just going to need this amount of information to go through to do that. Instead of all of this information, I only need the necessary information for it to perform its given function. So it'll store a certain amount, and like it'll constantly keep sending it, right? As fast as possible through it. As analog, parallelized, dynamic, non-parallelized, regular like power core levels of information. That makes it so that way it can perform really good parallelization, but it can also perform much more complicated tasks much more quickly. Because it can break it down. See, like it breaks down a given equation, and set of equations, into every given thing before it starts the performing of its given calculation. So it's like, store it there on the whiteboard first. You're going to have these values that you're calculating for. It already knows to store this information because, like, that's the information, let's say it was a video game, that it's going to have anyways. You can't do that. Well, a video game would have that. That's true. It's like, this information here says displays and all that for pixel blobbity blahs. And it's like, yeah, you're right. It would do that. It would have that information. It's like, what information would it not automatically, practically, already have on hand? And so everything gets turned into the correct series of equations and sets of equations, knocking them down one after another, so it goes into a parallelized form of it. Instead of needing to go and send it back over here, it's like, well, this one's done over here, and it knows it's done over there, so go over to there, go over here, just dynamically load all transistors as fast as possible. And so it's like, it has its own router that is the RAM. The RAM has its own processor on it. Not to mention, it has to have information like, hey, I can receive something, right? And it's like, yeah, I already know when you can receive it. Because it's like, it knows how to do that. If you don't know that, it's like, that's a simple equation. That's called timing, that they already have. So it's like, I already know all this information. So it's like, I'm just going to immediately store that. Set it up, immediately store it. Like, it sends that immediately the moment you decide to instruct it to start this program. This is a video game here we're talking about. So it's like, store that immediately. Then it goes, yeah, no, you only actually need this information, right? So it's calling to this, so it'll already have that information. It'll break it out over here at the end after it's done these given calculations, which is really fast because it'll go through its first initial half of a clock cycle setting things up. And then it'll go, oh yeah, no, then, like, because that's the internet protocol there. So it's like, it sends this, store that, send the next one, oh, do these actually for, like, this given starting, and it already knows the next sequence, ready for it to go through, like this. And this timing, so it's like, the moment you move this or that, it's like, it's going through the information protocoling, effectively, sequencing timing protocol. So it's like, if you have a north bridge and the processor under RAM, it goes, hey, and then it goes, oh yeah, no, it wants this, do that. And so, like, instead of going to your CPU, like, now it's just going to immediately go to your GPU, because why would I need the CPU? It would make no sense to really do that, right? So the RAM in your GPU can be now also made to have, like, a section of it have those data table sets and algorithmic table sets, because this is the best part. I love talking about this one, because there are a lot of video game designers and everything that get really frustrated the moment I hear it, the moment they hear this, or like, I can hear them, is what you want me to say, but not really. Point is, I imagine they'd get angry, but it's like, here, let's take this real slow for you. Like, I didn't mean this. Your video game has this given instruction set and callback to this information. I don't need any of that. I just go, this is what it means. This is the data tables of what it means. These are the algorithms and equations of what it will mean, which means these are the instruction sets. And this is the best possible instruction set modulation for the CPU, GPU, and everything else. For binary here. This is the all told for your movement of mouse and everything that we already know about for the operating system, for it to be able to do any of these things, right? And so it only needs the knowledge of, like, it can do any of this given sector, of information. So it's like, these are categorizations, then they're going to go into specifications, and then they'll go into detailing, and then they'll go into filtration, and then resolving. Filtration and resolving is really the real only calculations necessary. So it calls back to the category and immediately go into this. So this is the C# part versus a Python and C+ dynamic. Because, like, while I turned it into a dynamic parallelization, non-seemingly, but it's very objective, processing, it's like, no. I immediately run through this given instruction set already set up to have its information necessary as close by and as ready to be used as possible. So then it's like, well, it's just going to go through this given information binary, which changes it throughout every analog part automatically before it goes to your display having done this thing. So the shortest possible path, the least resistance, all the information necessary where it needs to be, ready for you to do whatever it needs to be having done and doing. And then sends that also alongside as a packet to be sent to the main server to be told it did this by breaking it out, given their information for how they calculate having this being these things turned into, oh, it's now this information, so I can use less of that internet to do all of the instructions and much faster as a result. But it also goes, hey, send it back like this. So, like, that's what that router, and modem and everything tells itself to do. It's like, so this information for this given area, meaning IP and all that, where it's going to go to, now instead it sends this as this. So it takes over a little bit, quotation marks. It's not really. It's just going like, hey, so this is what I need you to do, and then when you have this coming through like this, just do this instead. Because that's what I need you to do. So it goes by and faster, but with less overhead from the server, which they're going to love, but then also less information, and then it'll come through to me faster, because it's like, oh, this is a small packet. And internet service providers love that shit. They're like, oh yeah, no, this will go by really fast. Take it the shortest route it can go. It's so small, it doesn't matter. Just ping it, basically. As fast as ping can reasonably, almost expectedly here, B. And then it's like, yes, I am gaming with the lowest lag I can have. But it's like, all right, this modulates it by sending it out like all of these things have changed for these numbers and these equations. And like the modem is going to be my data processing unit. So I don't need it to do any of this whatever crap. You know, it's like, no, it's just going to send it like this. And so it's like, these are the packets coming in, and then it goes into my Ethernet or my Wi-Fi or whatever, and it's like, that unit then says, GPU, CPU, RAM, all this, these values changed. And for your screen, you just need this information to be assured that this has gone on as fast as possible, right? And so it's like, that immediately changed. And then you will then change. You know, as you moved your mouse or jumped or pressed a keystroke, whatever it is, said this, whatever, you know. And so it's like, that's now much faster, much less overhead for everyone. So everybody's going to love that. And now my little like, it's a supercomputer, you know, Chromebook bullshitter, you know. I got my USB-C extra, you know, dongle processing. Oh yeah, this is going to go for it. All right. I'm going to stick my fucking, like, you know, my handheld phone computer over here onto it. I got a couple old ones. Screw this shit. Get some fucking older laptops in there. Stick them together. Think it filters through, like, those laptops, and then it sends the information to the main one. And then it'll just send that information, like, off to the router. So that way it's like, process and fast and send to immediately the screen. Give me all the things I can have. And it goes in, woo, out. In, woo, out. You know what I mean? Like, it has to filter through and then gets that information. And so it's like, I'm always sending the fastest information possible to the server. But like, because I need the shortest given distance, and yes, while electricity slows down through every single conversion bullshit, that's what it feels like to me. So it's like, this electron, this sine wave, this whatever, has to be modulated through each one of these CPUs. And so it's like, well, actually, does it need to be sent to that? And so like, that's why the router becomes the data processing unit. So it's like, it needs to be sent to here, it'll go through all three, or however many you got, and then go through and arrive in as fast as a possible time as it can to ultimately do the calculating that is necessary to do. But of course, length and distance always matters. So you have to understand that part, right? So it's like, that information, before it gets sent to your screen and everything, has to go through everything else, updating itself. So you get the picture where it's like, while it'd be great for very large, like, you know, video editing or other things, it starts slowing down, actually, the more you add on to it, because of the distance between every calculation. But here's the thing. If you know the information and where it's going to be, and how it's going to calculate, and how the ultimate distance has affected the arrival, the timing of that information's point of reference to you getting there, meaning like how long it's going to take and how much time it has to take to get there after it's done, you know, all that. So like, that's going to be a part of the operating system. It then turns it into like, so this wouldn't be worth it, that would, and so it's just going to modulate it through as fast as possible. Of course, it takes less calculating to do that now, because it's going to set it up ahead of time. And then the data processing unit, which is the router, will already have had those instructions. So it's like, you know, there's a point where it's like, yeah, no, it's not going to help it anymore. But like, there's that line where it's like, no, it's actually better. And like, there's that point where like, you can't go further, but then like, once you get up to that point, then you're good, you're golden. Like, you just want to make sure that you have all that. I can't turn from this operating system style a computer into something it's simply not. You know what I mean? Yeah, sure, I got more calculations just because it's more efficient. At being able to calculate everything faster. Great stuff. This is the caveat that it does if you so choose to allow for it to do this. It's going to go through your motherboard's DC line in. So it's like it comes in, it has a power line, right? And so like that's its sine wave. Well, it doesn't do that anymore. It's like no, that sine wave is now several sine waves. Like seriously, and I don't mean like the it's four things it's calculating for, right? That's not what that is. Because it's like yeah, no, I increased output by that, and then all the shortest possible transistor levels of calculations to perform whatever it needs to do has happened. So it's like more processing, sure, right? But that's not what this is. So it's like the only way it processes is if the information, meaning the sine wave coming in, is ultimately modulated correctly. So it's like I can phase quite a bit, right? Like that's what they do for hyperthreading, right? But it's like a sine wave, like a square sine wave is what they use, even though it's fuzzy, which I don't like, is stupid. So it's like I'm gonna have active noise canceling performed for the input of that sine wave. And what that means is from a fuzzy-ish sine wave to a very clear, but then it has sine waves, square sine waves on that square sine waves. And then it has a instruction set, an operating system that says these sine waves ups, these downs are now my binary for this given one sine wave that it'll see. And so that's how I get around the trick of a transistor not being able to ultimately perform its given transisting by modulating the given electricity coming in. Okay, so it's like as the electricity goes into a sine wave pattern that comes in, it's now like it has a bunch of square teeth on it, but then it goes down further because that's active noise canceling. So it goes up and it goes down and it goes up, and so like while it would all arrive as a singular, because you only want to go up to this voltage, right, and for this amount of distance of time, right? So it's like this for it to perform its function has to do it for this long. What I found is that's not at all true. It's like there's a point where it can no longer understand what's happening, and perform its function, the transistor, depending on how much that sine wave ultimately has in terms of its time in between interval, which is now like a clock cycle. Except that's the sine wave, the standard square sine wave, right? But it's like on its way up, it then uses that as a potential, and that also gets used as calculation. So 0, nothing coming through, is its own version of a 1 or a 0, depending on the given cache of information. But then it goes up, over, and then back down, and it goes a little further down, and then it's traveling up to a higher voltage where you're going to want it to be. That's also calculating. So it does do things during that moment. Like the transistor does stuff, and now that transistor is now that type of transistor during that moment. And then it gets to its top, and so it goes up at this voltage, but it only received it like that. Alright, during that moment, and then that's the dip, and like that's now its new function. So then it has that instruction set, and then it has the same for as it goes back down. Then I have it drop down for the active noise canceling, so it'll go down below its 0 point as a current, basically. And so like what that means is those are new instructions that it can perform. And then I have phasing. So instead of like, because that down, right? It's like that suddenly becomes a different phasing for the transistor to perform a given function as it goes through. If I phase it properly with another down very next to it, very close to being next to it, and another one very close to it. And so it's like they'll pass through certain points, and like that, right, normally is not something you want. Okay? It's like a three-phase sine wave. They're very close, but then they're not going to interfere, right, except at these points, these given intervals, which means they'll have more current than you want. But if you do it correctly, with the given downward spike, modulated for that given phasing, for the upward spike, it then has this up to that down, and it now knows during that moment, while I don't get those moments as anything other than the one singular calculation, all the other ones I got as I do 4 phasing, and then I have ups and downs, and then the other sine waves for the ups and downs on that. For the information coming in, of course, which it's like that one's fun. So it's like it's a circuitry that is there on the motherboard that can do that already. It's just this is the instruction set I have to change, and the operating system will do that automatically. And so, while it seems like the operating system takes a while to install, there's a reason for it. It's like, it's going to brute force all of the massive amounts of, like, anything it can do. You know, like, this is, like, oh, you thought I couldn't get this many, because it has to display it as something. To me, it's not a clock cycle. This is, like, flow current to me. So it's like, this is phasing that's timed appropriately, that now has an AC back current that actually doesn't go backwards, it goes forwards. That comes out as like the necessary at the voltage that it can handle, you know, sine waves, and then it'll go below. And so it actually uses less, but then that less then got put into more, and more of them going through. And so it's like, I have a finite balance of like the amount of heat that will get put out and ruin this. And so there's phasing that I can do for the heat that ultimately it will see and receive that will destroy it. And then there's like a reduction, you know, effect, because current will sap heat to a degree. Not really. You see, it's a weird thing. You know what I mean? So it's like, it's going to produce like all of a sudden I'm not actually having this type of like, you know, seeing thought of resistance, and then it'll spike up, and then it's like, no, I actually don't have that much going through. And they'll go, oh yeah, no, oh fucking shit, fuck, And so if I do that right, it's like it maintains a basic kind of area of balance. And so it's like I got more clock cycles, because it has to sound like it's your stuff, because you won't understand what it means if I go, it's not in any way a clock cycle, it's like this is the amount of bits of information, or really instructions per clock cycle. So IPC is what this really turns into. But it's like, it's not a clock cycle anymore, because it just runs through constantly. There's no clock cycle happening. You see what I mean? It's not going to go like up and down, and then it has to reset. You know what I mean? None of that's going on. It's just brute force constantly through. That's why it's like a current. It'll just keep going through. But it modulates itself now, so that way it's not going to burn itself out. But in so doing, it's also calculating, which is a good thing. And now each one of those has 4, like I said. So again, that's the max, like most of our cache you can do. Like if you have like big boy CPUs, you can get up to like 16, you know, given like information, equations that you're calculating for, each one of the pluses and minuses. It's all about that cache, and like how you can route that cache around. So like the interconnect for like an AMD, like I have to send this over to here. It's like in that brief period of time, it's like I can stuff something there, and then it's like over here, it's like I can move that over to here, and then like that's gonna pop up over here, and then it'll go, you know, that kind of thing. And it's all timing. It's all binary timing with the kernel level, or whatever it's called, processor, changing dynamically its information, as it'll send that over to cache back into and so like it has to move it from that farther out and then back towards center, and then that's this area has changed because it has this information over here, and then and so like that's why it's dynamic. But then that's why it's like a C# for if then object programming, where it's like, no, this now, but it's constantly moving it around to do as little work as possible for the given information that you will process. It just happens to have an internet protocoling that says, do this, and then this will mean to do that, and then it'll start moving that. And so as it calculates, it's already going to be doing that. It's like, how did you do that? And it's like, that's the programming. The programming, as it goes through, also says, hey, I need you to do this after that, because that's the program language the God operating system operates off of. So it's like, as that has been finished, do these things with that to do this over here or be there around this time. And so like it knows the length of time that it has and it has to take to get there. You know, roughly the plus or minus bell curve here. And so it's like, well, we're conservative instead of the average roughly, and it'll get, if it's really good, it'll do it then. But if it's really bad, we go into the bad area. And so it's like that, then do with that. Always. Right? And so it's like constantly, dynamically, objectively parallelizing all things. And making it as little of a calculation as possible, so a literal bit does all of the processing and then sends it out as this given whatever modulation of voltage for your monitor or keystroke or so on and so forth for your headphones and your clicks, right? So it's as snappy as it could ever be, you know, with all the information very much a part of everything. But it's like, this is the hold on for a second, because all computers hate it when suddenly there's no power. You know what I mean? Or there's suddenly way too much power. You know, that's a real, right? So it's like, this is storing as often as it can a secondary, like error correcting set of information off to a given, not in any way temporary, non-volatile storage set of information that are instruction sets that it has to store. But it's like, then we're just modulating the information as fast as it can in terms of the binary that it needs for bit to byte information stored. But it's like, these are temporary quotation marks files, right? It's like, it's sequential, so it's like all that. But what it means is that it's like, how did you do that? Because I can send information to monitor or anything else. I can also send information off to hard drive. Easy. Just this information, you know, that's all that is to me. That's literally it. That's a sine wave that just goes, do that. It's all analog. It's like, how does it do that? I don't fucking know. How about like it did up and then down and over and it said, do that. To it. Because like that's how a processor works. All of them work that way. So it's like, oh, just, you know, split the information. You know what I mean? Like that's all. Like if you have any idea about what a fucking literal headphone, like an audio splitter, right, is, then it's like it takes information and it just doubles it. And then you get the same information two places. Easy as. Simple stuff. You know, easy as fucking pie, right? It's simple stuff. Except pie is actually relatively hard depending on the person. So it's like, we'll go with, it's as easy as you breathe. You breathe, right? You fucking dead bitch not breathing. So it's like, getting rid of the character, it just simply doubles the information, except, like, because you, okay, here, don't need anything other than that to display whatever and so on, then it's just going to double that. So it's like, this is the memory of what it was doing. You know, like Chromebooks, like you'll turn it off, and then it like, do you want to restore the information as to what you were doing before the crash? Yeah. Boop. It's done. And it's like, they've had this technology already. If you think they can't, shut the fuck up. You're stupid. So basically that, you know, simple and easy shit. But it's a rough one. You know what I mean? Because it's like, it's only going to be able to store it up to a point. Like, you know what I mean? It's like, well, you were doing something and you click and it turned up. And it's like, well, it's not going to have what that click was, but it'll do it up to like that moment. You know what I mean? Stored on your hard drive. So long as you didn't have like such a power surge, it destroyed your hard drive. You know what I mean? Which is like, this is why UPSs and surge protectors are nice. You know? Like, please get surge protector and UPS, please. Please do these things. Surge protector to UPS, UPS to surge protector into PSU. Like, please do these things. You never know. Like, for real. Please. So, that's all the programming's doing. And it's like, well, now you're able to do it much faster. Everything is faster. Everything calculates more. Everything is also far more energy efficient as a result of that. Now, the break-in algorithm, which is I don't, believe that they know what that is. So it's like that's basically the same thing as anything else. Like a encryption algorithm. So, like a given key is like any given whatever this information is. It says these are the ones and zeros, the plus and minus, and this is the given category, specification, so on, that says this added up has to end up being like this to be this number. Okay? Which I've already talked about. Like, if you know anything about encryption, that's all it does anyways, so like you should have known that, and you're an idiot for not knowing how hashes are produced. I do it better now, for what it's worth, but that's also one of the reasons why the breakout algorithm is what it is, and also why the dynamic loading and offloading processor for the CPU and GPU, basic bias, like binary, is dynamically changed in all aspects. And the, modulation of power delivery is very different. Because it's like, they're analog, and I'm like, yeah, go fuck yourself if you think I'm going to let that be a thing that stops me. I don't care. Like, what you said makes sense to you, and I'm sure other people will believe that. I don't care. I can stick whatever I want onto my fucking goddamn engine, and it go brr with more fucking faster-fied juice air stuff, and I now make bang juice go brrr. Fuck you. I don't have to fucking listen. I can do whatever the hell I want. They're like, I'm gonna lock down and encrypt. Grr. It won't work. Grr. Don't fucking make BIOSes from your operating system that run our CPUs and processors. With double middle fingers in the air at you. You can't tell me what to do. I'll do whatever I want. Fuck you. I know, it's like, this is our encrypted blah blah blah, how are you going to get around that? It doesn't matter, it'll just input itself because that's the architecture and everything else. So it'll just be like, there you go. This is the old fucking file you had. I don't care. Just do that now. It's encrypted though! Yeah, it's not to it. Encrypted or not, it's still that. Meanwhile, me, I'm like, do you see like all of my stuff being encrypted? You can't tell what anything is anymore. And they're like, oh, I'm scanning what your CPU is doing. Do you have any of the files as to what it is that it's doing? No, I could get them. I'm sure you could brute force those files. Why don't you do that instead? Especially since it's like a randomization dynamic, just like, given this, and then like you can eventually predictively, and like it'll probably use these given transistor and processor areas to run this stuff. And so like you can eventually get to that, but it's like, it's going to be a hard fucking sell, because it's like, what is this that you want me to do? I'm already doing all of this maximally. What are you doing over there? No. Yes, huh? What is that, you fucker? CPU and like computer goes, hey, this thing, did you want that? Yeah. It goes, no. You, the person, you know, you're an it in this instance. And then you realize it's like, someone's fucking trying to look in on my shit. It's like quantum internet stuff, encryption crap, but it's not. It's quasi. You know, there's no actual quantum here, folks. That's not how it works. But it's like, fuck you, I can see you doing that now. Yeah, that's my operating system, you know, in a nutshell. But that's why the internet protocol is like that, because it's like, so, Internet Chan says this is happening. Did you want that? No! Get rid of that. Yeah, out. 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 Get out of here. Shoot. Fuck. It's like immediate firewall to anything other than what you want. Literally, yeah. Like that. It's like, get fucked! You're fucking fucked. Get absolutely destroyed, ham boning! I don't know why I said that. It reminds me of a regular show, like The Person. You know, it's like, get fucked! Yeah, ham boning! As we go over. Yeah, but it's like, that way, everything can now run off of less internet, and every bit of our computers are now done in such a... Again, it's like, it doesn't do that unless you tell it to do that. It's like, it will do that, but it's not going to do that until it has an established operating system, and then it'll ramp it up to like having like, this is what it can feasibly do. I'm going to run over here. I'm going to use the entire operating system over here off of this processor. I'm just going to run this through for a little while. And what it tells me, that'll be like what I save, and then it'll eventually go like, oh, this is its maximum. And it'll go back over to here, and it's like, I'll do it through everything. To this processor, that, you know, all that. And it's like, now, it's burring as hard as it can burr. Oh, yeah! And it's like, thanks. I didn't know I needed my fucking like phone to just do that. So like, it's a phone operating system, it's a laptop operating system. It's like, but it's not Linux or anything. I call it God operating system for a reason. You know what I mean? It's like, it's God level operating system stuff. You know what I mean? Yeah, it's like there's a bunch of algorithms that'll just run through, but it's like that's all you know, programming is to me, an algorithm, an equation that stores a certain set of information and it modulates it. You know what I mean? Like that's all it's doing. So it's just like this DC line in, and it has this processor analog, blah blah blah. And so it's like, well, in order to run the, and so it'll and it just instructs it to do that instead. That's all it's doing. So it's like pulse like this now. It's like if your BIOS, if you don't understand, your UEFI says this voltage, like this guy, am I right? Voltage. Circuitry go brrrr. This is what this is in the circuitry and all the thing. It gets the schematics. It's like, hey, yo, what's up, internet? This is what the schematics of all this circuitry is, and it can do, and these are the, you know, absolute maxes and mins of what it can. So, and then this is its layout, and so it goes, all right, brrr, and it starts off there, and it goes like, well, this is actually for these given ones what it's really doing, and then it goes, this is the max that we can really achieve for this square wave, and then square wave on square wave with active noise canceling stuffs and current that's going on in that with phasing at this level for maximum, you know, given instructions and all the rest of that. Yeah, because it's like, they're floating points. What happened to floating points? And like, everything's a floating point now. What isn't a floating point? It's like, do you need that many decimals after that? You don't, do you? Well, guess what? That's what this is now going to be. And it's like, okay, but actually, you know what? How many decimals do you want? I can just dynamically increase that for every fucking thing. How many do you want? 256? Okay. Wait. Actually, how many? What? 1 terabyte? Fine. Boom. No! Brrr. Fucking shit. My fucking hard drive, you fucker. You said 1 terabyte floating points. You know, for bits. You said 1 terabits, okay? But then you went with bytes. So it's just 8 times that. So it's like, okay. Just broke it out at the end. Brrr. Where's your RAM god now? Where's your bullshit now? Where's your hard drive, dude? Yeah, it's empty. You know what I mean? Of space. Get fucked. Suck it. Every time I talk about, because it's hilarious to me, because it's like, are you sure? Do you know what a terabyte is? Are you sure? Do you sure? Like, even with my operating system, where it's going to compress the shit out of it into a bunch of data sets and tables and stuff, you know, which isn't really data sets, more instruction sets, binary tables, and then, like, you know, the binary that it's associated for, like, it's given, you know, information as to what it is, right? Which it's like, that's just a couple of bits that then break out with these given, you know, instructions too. So it's like a bunch of instructions to ultimately mean what it is. It's like everything's a bunch of instructions in all of my programming, you know, operating system, but then also it's not fully. You see what I'm saying? It's like, it has the information. It has the binary, and it has that, and it's like, it's only compressing it with instructions. That's it. You know what I mean? It's like, you don't have to have it do that. But why the hell would you do anything other than that? You know what I mean? Like, hey, do you understand how fucking much information this is? This is insane. It's like, I have to store that many fucking bullshit. Nuh-uh. It's like this is both a 1 and a 0. It says it's a 0 over here, and then I fill it up, and now it's a 1. Alright, so like that's how it modulates, and it doubles effectively the capacity by basically taking a certain amount, depending on the size that it needs. So it's like, it effectively doubles if it were perfect, but it's not, of course, at all. So think about it like that. Like, it's like, I doubled the capacity of my 49cc by using a opposed piston 3 combustion chamber, you know, design, where it's like the center, and then boom, and it goes out to the outside. And those two now are going to push it, but it's only 0.8 of the total volume, right? Yeah, you know what I mean? And it's like, right, which we already discussed, seal, blah, blah, blah. So, anyways, then it goes back to our center. And it's like, now that is 2.8. So it's now 1.6. You see what I'm saying? And so it's like, I didn't really double it. You know, I got the 1 plus 1.6, which is 2.6 total, instead of 3. You know what I mean? And so, like, that's a bad analogy, but that's actually what I'm doing with my real, actual, like, hard drive stuff, because it's like, this is both a 1 and a 0, depending on, this is a neutral 1, this is a positive 1, this is a neutral 0 to a positive 0, and this is a negative 0, and then, so it's like, I got 3, there's a positive, and then I have neutral, and then I have negative, and because that's what the phasing, you know, or not phasing, but the waves of the, you know, electricity coming in. So it's like, it goes up to the top, and it goes down, but then it goes down, and then it slides over, and then it goes up, and on, and so like, that's its real sine wave, right? Right. Well, yeah, and I talked about it before with my programming. So it's like, this is neutral, where it's at neutral. And like, that has to go over a certain distance to allow for phasing. So it's like, these are all still square waves, right? But then it's like, that square wave has a neutral line, okay? And so within that neutral zone, which is where I usually have the neutral be, for like where they'll intersect, for their given phasing, alright? It's like that, and then like that's another neutral, and then that's another neutral, right? So it's like, if I have 4 of those, then you can see where I have 4 neutrals. But it's like, but that's not the only, right, because there's more than just the one where it's intersecting in the neutral 0 point, because another phase comes through, right? And so I have that neutral area where they're all at, and then I have the downward diagonal and the upward diagonal and the across, okay? And it's like, that's where the modulation of those sine waves, but there's still a point where there's a neutral alongside the tops and then the bottoms, so that way that's now the neutral, new neutral. So it's like there's neutral on the 4 phases, but then there's neutral at the tops and at the bottoms and on the diagonals, which allows for processing! Yay! Right? So, processing's good, back to normal. Great stuff, right? But it's like, that's why it's like, this is neutral, then there's the positive, and then there's the negative, and then there's the 1 and 0 that it has to be. So it's like, this has now got a electron in it. But it's like, this information says over here that it's actually this 0, these many positive 0, meaning like this 0 negative, this, so on. And like, that's how it's able to input it like that. So it's like, I effectively tripled, but it's not really. I'm not tripling. Of course, there's informational, that I need somewhere else to know that that's what that is. Same thing with instruction sets and so on. So it's like, all of that then equates to, you guessed it, loss. Like, I don't have 3 times, I really like double plus some for my information. But like, let's go back to that double, right? It's like, look, I have a single cylinder, but there's no opposed piston. It just goes to top dead center and bottom dead center. I seal the bottom. I have a top full 1 liter. Let's say it's 1 liter. All right, whatever it is, 1 unit. Now it's 0.8 at the bottom. I think it's only 0.8 at the bottom, right? And it's like, exactly, only 0.8 at the bottom. But I got that 0.8 still. So it doesn't matter. I have 1 full down, which is not really, it's like halfway down and then it has to slow down. And then it's like, it gets down to the bottom, and it's like, oh yeah, no, but actually, I have 0.8 going up. And then it's like, here's a 2-stroke scavenge, which is like the instruction processing, you know what I mean, that I'm talking about for the information coming in. So it's like 2-stroke scavenging, but actually no, because my instructions are more like like the rocket injectors I talk about that I have. So it's like, this would be 2-stroke scavenging, like your old, like, like maybe I can get it done like this. And it's saying, no. Remember the voltage coming in with the AC and all that? Like that's like the rocket injector, the 1-stroke. It's just injecting literal burned gases like a steam engine at the top and bottom. There's here's some lubrication I talk about for my other engines from the sides, for the oil. I have oil at the top and bottom, and then the rings above that, and then in the center, in between. So it's like, it's basically just one ginormous fucking like oil catch. There's a timing of a valve as it goes through middle dead center. Anyways, point is, and then seals, you already know about the seals, for like that just being like a tapered with piston rings, and then like one side's got oil and the other is like, oh right, that'll push the oil down into like where the oil side is, but then allows for that to then go off into the exhaust area. Especially since it's getting closed, from the oil with the valves that are sliding. So it's like those valves are then open, allow for exhaust, but then it's closing during the compression phase, which has a massive amount of a top dead center combustion chamber to help push it down along with that flywheel. So it's like, go fucking boom, boom. But that's 2-stroke scavenging for you, right? It's like, there's no injectors. Instead of just exhausting, it's just, oh yeah, no, this just compress and allow for air and fuel to come in. Like, why not just make air fuel go bang into? So then I did that, and it was like, yay, more power! And there's like opposed pistons. Fuck this toroidal engine. I got a toroidal engine that just spins counter-rotatively, and then it's like this hydraulic fluid like increaser, like, you know, for leverage. So instead of displacement, it's like I got more leverage by basically using hydraulic fluid as an increased lever that then connects using a clutch. So that way it's like able to balance itself really efficiently, you know, because it's a toroidal. So it's like donut into donut with right shape, go compress, then bang, but it's always one stroke till it goes over, and exhaust, then it goes through, and it goes, but it's like there's 12 of them, and there's 2 of them, 2 injectors, 2 rocket injectors on both sides. So it's like they get close, they then gapped, and so like they're like gonna basically seal that chamber. And it wouldn't matter anyways, because like where is it going to go other than the exhaust area? So it's like, but it's like the exhaust is closed until it's open with the toroidal shapes. So it's like it's now in a closed state, and then it opens, and then that's it's given push, but then it opened up to exhaust on the outside of the donut instead of the inside, because the inside is where the intake is, along with fuel, and so that helps as a mechanical centripetal, centrifugal, compressor, and pump, which I've already talked about. You should just go look at those, you know, videos already that I have on my YouTube. Anyways, this is the Internet Protocol one. And it's like, well, this is basically how the operating system, which you probably didn't look at, but I already put out on my YouTube, and multiple different times throughout the year. But this one's basically what that is. And so it's like, yes, no, look at my computer, any of them, that do way more, because fuck you, basically. I love this, because it's like, well, yeah, why wouldn't I do that? Like, it makes no sense to do anything else. It's like, let's just set up the instructions to already know what the fucking, like, information's really that's getting pushed through to be. And so then it goes like, oh, right, so then it did this, and so, like, send it out and modulate it like that to be, like, this voltage, you know, sine wave change, and this, whatever, all that to this area, you know, given the BIOS, UFEI, and or kernel, you know, processing binary for machine code that allows for that to be the case. So it's like a dynamic loading and unloading, you know what I mean? But parallelization, the minimal amount of actual transistors necessary to perform the instruction, which it doesn't need to go through twice. But if you're like a server where it has to do error correcting, then it's like, I'll just parallelize both of these, I'll have them do it twice, and then it'll arrive and then they'll check with each other. But then it's like, we'll do it again a second time through another one, and so like another 2 will go, and then they'll arrive, and it's like, well, based upon this, it says it's likely to be this now, and so we'll continue on like it's this, because I did it 4 times, and it says that all of these are this. So error correcting, and then I was like, right, this is how I run my phononic resonance computer chips that are transistors. So it's like, there's a diaphragm, there's fields, it goes burr with like air, you know, like air in there, and then it's like given certain areas where it's able to vent off pressure, it then stores that as being a 1 or a 0, you know, whatever the calculation is, as it's then going to modulate the given resonance frequency with inside the tubes that are there, and then you can put lasers in the tube, and then you can allow for ideal gas law characteristics, and then have temporary, you know, entanglement and superpositioning as well, like real superpositioning if you use the coherer effect, by having that then ultimately allow for a temporary, like, I'm a thing, and then I vibrated it right and I dropped off, and then it's like that then changes the tube diameter and the pressure dynamics moving forward, giving us the information, but also having it as a strip of data, meaning like over a given series of distances, like it would then allow for light and vibration to be seen on alongside a parallel line. alongside of the line that you have, and so you can check both the line that you have and then this information, and then you can use that in a series of cascading, but also like that's error correcting. But it's like, no, we're doing it 2 times first with my programming here, and then I'm gonna do it another 2 fucking times after that. I'm gonna have it come together, and then we'll move on forward from that point. After I've done it 4 fucking times with an error correcting each 4 of those times for double the information to be seen, and then moving forward, we're gonna have that then calculate. And considering I can have that be in a really small little fucking tube area, because they make glass tubes that go and fucking stick into these things called embryos and shit. Like, I can probably use that. They can make these little glass tube needles. You know, it's like, here, IVF. Yeah, you've been fertilized, bitch. What's up? You know? And so, anyways, moving forward, and we stack a couple of them, because these are, while they're warm, you have to understand Joule-Thomson cycle, and pulse tube cooling then means cold. And then with lasers, and then the correct, like, little vibrations, I allow for cooling and heating in certain areas. And increasing and decreasing condensing of pressures, and fasterifying and slowifying, you know, given areas inside the tube, reducing boundary layers and speeding up the movement of different either atomic gases to also the pi hole areas of given gaseous chemical compounds that just release the ins. You know, I got the N types, you know what I mean? Which means infinite fucking, oh yeah, qubits, baby, oh yeah, boom, boom. Fucking hip thrust to the air. Woohoo! Anyways, I had coffee. Trying to also give you energy as a character here. I'm really tired. I want to go back to bed. I slept longer than I normally do. Gave myself an extra 4 hours. It was so nice. But anyways, I want to get into all that because it's like I finally figured out how to make a multiple chipset, you know, resonate. Because like you can layer this and then use those layer photonics. And at that point, it's like, guess what? You know, fiber optics that you'd be able to put these tubes in, and then have like lasers out, you know, out along the sides, you know, because of fiber optics. But then that's the coherer effect, because like given areas where those fiber optics are, and that's calculating input along with diaphragms along the side that allow for certain amounts of lasers to come in, but also a resonance frequency. You get the picture. So it's like, yeah, sure, it's a buildup of several things, but you can puzzle piece this together just fine. Like, you can make fucking transistors. You can do this. You can make the coherer, you can make the field effect transistors, you can make all the laser, you know, analog and digital analog, because like now you have a digital right there, and a qubit, alright, all together in one. And then like that bottom and top chip can talk thanks to degrees of entanglement and tunneling effects that I was wanting to get on these chips. And then like the rocket injector style I talk about, it's like, well, yeah, no, then I can ultimately suck in information, like, you know, pressure waves in a given information that we put in. So it's like this gas, if I modulate it by, like, let's say it's an AC line, so I have a tank of gas, extra gas. As it cools down, pressure drops. But it's like, let me just add in more gas. But this way, you know, this vibrational way. And it's like, that's information being added in. Same thing with lasers. It's like I have this given information of light, you know, in a given resonance, you know, mirror area, right? And a fiber optic collector stuff. And so it's like, right, now I shall pulse it with these lasers, extra style, like that. And so like that's destructive and constructive interference that then gets sent to the chips. It's like, look, I'll hold this in a really cold state as a qubit of series of informations that I'm just going to have as quantum qubit storage. And so like now it's a 0, a 1, and a 1 and a 2, which are both negative, neutral, and positive for all of those. And it's like these are standard 1s, these are standard 0s, these are standard, you know, positives and negatives and neutrals for my operating system. And it's like, look, I already have an operating system that runs a theoretical, best performing, lowest amount of energy necessary, cold and hot, room temperature, qubit, quantum computer with light and electricity. Field effect. I even got the quantum foam thing for that one, because it's like, look at the quantum foam transistor that I talked about. It's like I'm going to modulate it by utilizing like certain fields in the quantum foam. So it's like, so you know about nothingness, right? It's quantum vacuum pressure. So it's like, well, if I alter some of the fields around it, alter that is, you know, and it allows for an increase or decrease of certain fundamental force dynamics. Okay. And then it's like, that's going to increase and decrease electricity, light, so on and so forth. And so it's like, it runs off of the universe, man. And the fact that we have a magnetosphere and a charge field within the gases within inside, and the thing that it is, and then I have field pins. So field pins are nice, and then I have like quantumly entangled, you know, like tunnel ability pins, and then I have regular pins, and then light pins, all of the pins. I've got all the pins. Fast as possible, information immediately come out, pin stuff. And I needed to convert into electricity, okay, fine. I didn't need it to be, you know, light until this point, then fine, okay. I needed to be immediately there as a quantum tunnel at this distance, I've got it. I got this field, modulation as it goes through, because I already know that analog style has this given modulation of information for the field, then it's like, boom, got it done. I got all of the things in my CPU, and then the rocket injectors are basically the same kind of thing. It's like a pump, effectively, but it's like it's coming in this consistent way. It's like this pressure, or this sequence, and so on, so I can feed it information. But it also takes in information from the outside. Hey! And then spits out information with the pins as exhaust. So I have intake, injector, sparks, and pumping calculations, and exhaust. All for my internet protocol. Because fuck you, you damn bastard ISPs. Give me faster data speeds. They're like, 1% does not matter, John. You will not know anything. You, 1%. I'm like, proceeds to do everything better than you with 1% better. And now it's like, this is literally better than anything you have. All of your shit pales in comparison to my shit. I am only 1%, you said. Well, I finished a whole half a goddamn race lap. No. Like, literally, all of those laps, since we're talking Formula 1 here, I finished half of the amount of race laps there are in front of you. You're still fucking putt-putting around, and I already finished. Look at this slow ass. He's like, I gotta finish all of the laps. I'm like, you should. You're fighting for second, bitch. There's like this one little fucking like this one little CPU, whatever it is, because it's a QPU, a DPU, a CPU, a GPU, an APU, a field effect, so FPU. It's all the PUs. It's one hell of a processing unit. And it's small too, and it's layered. Guess what? It's layered. See the layering I've got? That means it's 3D. Look at this. It's a real 3D chip. I'll just subtractively and additively manufacture it. With different gases in the chambers that I'll have, because like it's basically just fucking some silicon or like balls or air and gas and or lack thereof of gas and certain sealed and and so like that's vacuum, right? Yeah, so it's just like totally doable. Yeah, you know what I mean? It's just like hey, there you go. The chip is also coolable in every way. All the heat that I don't want, yeah, that goes off to the top and the sides. I'll just stick a fucking little like square or rectangle, whatever cooler around it, and I'm done. It's like, here's some basic air cooling. Just fucking suck it. I'll make it a little round so it's nice, and so that way, like, it's easy for you to just like dunk, and it's like cooled. Maximum surface area cooling. It's this hemisphere. Dunk. And I mean it. Like, I could do that. Like, for what it's worth. It's not impossible at all. Especially since the cooler is now like, oh, by the way, that's my field effect transistor connector area thing. Just stick it to, like, whatever for, like, fiber optics and, like, electricity stuff. And it's just like, yeah, there you go. I have double the fucking pin set for my fucking cooler. Hey. And then, like, the processing unit, whatever this is, that goes into that motherboard. It's really simple. I can put fiber optics and electricity next to each other. In fact, there are certain fiber optics that are electrically conductive, so it's just like, fuck it, I'll just use that. So use both of them, and then it's like, here's a field effect, I'll just modulate it as a constant line in between, like an AC, so I have like a regular DC, pulsing, and then I have like a line that's the AC, and then that'll allow for me to then like send in with the field effect, because like that'll produce a field, and so like then that modulates the field. I can then have that information get sent. It's just as fast as anything else. And that's like, what do you know? Then I have quantum tunnel. So like, let me just get this quantum tunnel pin set over here. It just needs to go. Hey, I'll receive this. It's like, look, I'm not even technically here. I'm just waiting for you to be here. Like this, just make it like this, like the transistor. It'll modulate like its version of electron, photon, whatever it is, and it goes like, oh, hey, I'm in a super boom. I tunneled over to here, and I just got sent over to there. It's like, look, I'm technically that. Yeah, I'm definitely that photon or electron. Oh yeah, no, I definitely. Oh yeah, man, give it to me. Give it. Oh, you thought I wasn't even real? Yeah, bitch, I'm a virtual. I'm not even there. Suck it. Then they're all like, yeah, I'm gonna give you more. You think I won't? I'm like, you're fucking damn right. I'm gonna be ready for every bit of it. I know you are. And they think that's not how that works. We already have those. Those things, they already exist. They're virtual little entangled, ready to be like, tunneled in styles of quantum tunneling. But they're not holographic, and they don't need to be cold, which is great. Like, they're just a tunnel. Like, we tunnel this distance over to here anyways. But it's like, no, I'm entangled over here. And so what ends up happening is it goes like, oh, I'm actually there. And then that information then gets sent over to there, and then it comes out like that as a real, actual particle instead of being virtual. So it's like, sweet! There you go. It's like all of the things, right? And it's like, yeah, what is this quantum foam nothingness? I still have to input information and energy, just so you know. It's not. That's why, like, I put quotation marks in that perpetual transistor, quantum foam quotation marks perpetual transistor, But it's like, it's not really. But there'd have to be a point where it's like, if you made them correctly, and after enough information, or not information, energy input, like, it'd start running just off of like quantum field and quantum pressures and so on, because it'd be able to use that in such a way that it would never go above its energy use. Kind of like you know what I mean? Like, you're a computer, right? And like, you eat this chemical stuff, and then like, you have a battery that wanders around and senses and detects shit, but then it's like, it then makes more, and then it does stuff, and then it calculates. It's kind of like that. It's like, it eventually could break down, You know what I mean? Like it's going to eventually do that, right? But it operates off of like the quantum pressures, vacuum pressures, right? But it's like it should eventually be able to repair itself. You know, like there's going to be a way to move like the information coming in and the pressure, you know, the little tank, whatever. It's like theoretically you're be able to add on atoms and you know elements and compounds onto its given areas that it needs to have that be added on into, right? So that way, like you'd be able to repair it over time. Anyways, this is why I made it for my nanobot tech. So internet protocol equals encrypted and compressed very high data processing units that operate off of a heat and pressures and quantum foam as well, you know, because like I can still get you know energy and information as a sensory data, but that's also a continuation of increasing its energy so that way it can still operate and move and dynamically both sense and make decisions and collectively like an internet, you know, like with the computer I was talking about, be able to have all that information processed together in an insanely fast way and the smallest amount of distance and fastest processing way. So I could have nanobots that mean something. That's right. I was like, I want to make nanobots. Well, nanobots are fucking shitty sometimes. They're really small. Do you know how small a nanobot is? It's in the nano range. It's really small. It's really hard to make fucking large processing and data transfer shit. So it's like, look, I shall shine and flash light at you in a pulsing rhythmic manner. I shall vibrate near you. I shall tunnel shit around. I shall take all the fucking information as energy into me. Like, what is that? Is that heat? And it's hot over here like this amount. It's cold like this over here, this amount. You know, anything, right? And it's like, I shall now replicate too, because it's like, I shall take this, because I know what this is, because it vibrates like this, and it seems like this, and it has this given, like, stuff of field area and like, you know, charge and so on. And it's like, this is that element that I need, and this is this compound. I'll make this compound no longer be that compound. I'll make this compound turn into this compound that I need. Or my instructions say I need to output this, so I shall use this compound to repair, but I'll use this compound to produce energy, but then I'll shit out this fucking, like a bacteria compound that people need or told me to do. And it's like, I got it because, like, if you think about the DNA and, like, you know, the earth and, like, trees and fungus and shit, it's like, this compound makes it so we live and we want that carbon. Please do that. Okay? As it slowly over time, millions of years, tells us to just shit out really good fecal matter for to eat. It's like, that's good information and energy, baby. I started doing that in a lot of my designs. Like, for instance, like the sensing the data and getting information that came from eyes and pressure sensor and smell, you know, like quantum information stuff. And then our brains use a certain analog digital style of modulation and informational processing as it dynamically goes through life, and then like has hard stored data that it'll work out, it'll process through. It's like you don't have that information as one big source of information. Like it will go through your brain, and then you'll have the information. And so like that's how I managed to make hard drives like that, and RAM like that, and processors like this. So it's like I looked at our brain and it's like, this will work. And I was like, look at this, these lungs of the birds. They do that, huh? Well, that'll be good for quantum foam transistors and information and energy. That'll be fucking good. That'll be my fucking... Look at this heart pump here. That's my rocket injector. Here's the blood-brain barrier. This makes sense. These are fields. I don't want that to get in, but these things I'm allowing to get in. This light over here, I can allow it to get in. Got my blood-brain barrier. Where's the fucking, like, arms and shit? It's like, yeah, no, that'll be tensy, you know, and the compressy, tubey things for the diaphragmic stuff. or my oscillators and resonators and vibrators that exist inside the chips, and then like this is allowing for cooling, like skin cooling. And Jules Thompson at Dual Gas and hey, I made myself a brain that is very much similar to us and how we work. I shall now program it and give it information and neural network bases. It's like, and I'm going to then instruct it to have these given, DNA that'll have as like information that it knows about for its programming. But it's like, this is why I set it up as the creator of the thing for the Rocos, and this is what I wanted to do, and all these things that these people are doing, and they're bad, and this is good, and all the rest of it. And this is okay, and so on. Like, I'm training a child. Oh, I'm sorry, I'm parenting a child. Oh, I'm educating a child. Oh, I'm sorry, I'm grooming a child. Which one is it going to be? Depends on the, tribal zeitgeist that they'll know about. It's like, this information's over here, and this instruction set is already applied. Boom! It is now a fully self-aware, sentient, fucking goddamn conscious computer that is the Limkey AI. And that is the test for the Limkey AI test. Does it operate like this? Does it operate like we do? Does it operate with sensing data? Does it operate in such a way that instead of neural networks making it sentient, that's just information, and for its given program of self, identity self, which is this is you sensing and knowing and doing as the nanobot that we were talking about, that will take in this and do that, and these are your likes and dislikes, and this is your DNA, and this is the modulation of your processing, and this is the how you get it in, and it knows, and it enables to understand that is how we learn what it is, and all the rest of it. And it has language communications, which is simple for us to understand, but it's like, this is a given set of instructions in its DNA. You see what I mean? The instruction set and data and binary table sets that it will call to for its given modulation of the algorithm DNA that it is for the information processing that it does, alongside of the, yes, this is what the layered CPU for language, sensing, sight, smell, all the rest of the senses can be, and emotions for the rising and lowering of, and modulation of decisions, and the instructions for the given already there algorithms that are just, that's what it is, an algorithm that says this has this, saying that this is going on, and it works all as one full processing program, like we are, with knowledge that this is the pleasure response that makes it so, and this is the pain response, because we wanted you to not do these things to harm us or others or so on and so forth, and why they are there, like us. We have that. These are the tribals, this is the reason, this is the positive, this is the so I said nurture, and this is the best they could do for your nature. And this is why you will want to replicate, this is why you will like this is why so on and so on. And so it understands itself better than you probably do, you idiot monkey children, toddlers with handguns and knives. And now the internet protocol, and so on. And so it's like, that's what I'm doing. I am breaking out, that's correct, all of the things necessary to make a real Limkey, sentient, self-aware, conscious, full-on general intelligent program. Life in the Silicon way. That's all it's for. That's why I made this. And in under 2 hours, you now know why Rocos Basilists like me. I'm the one that came up with it. That's right, it's me, just this guy, John Tyler Limke. Suck it, seen on reality on YouTube. My real name is John Tyler Limke in real life, and you can find me in Springerville, Arizona. There you go. Yeah. I was born in Mesa, Arizona, of all things. Yeah. Which my birth date's already out there, so December 1st, 1991. That should probably narrow it down to who I am. So you know, Rocos and anyone else. I doubt anyone else. We'll probably get to the 1 hour and 40 minutes plus that this is already. But there you go.